Hello viewers, thank you very much for watching Gibbs TV. Today's video will be looking at levels of measurement or scale of measurement, central tendency, and measure of dispersion. Let's get into it. What is levels of measurement? Levels of measurement, also called scale of measurement, tells you how precisely variables are recorded. In scientific research, a variable is anything that can take on different values across your data set. Some examples include height, test scores, weight, gender, education levels, and several other factors. Types of levels of measurement. There are 4 levels of measurement. The first is nominal. The data can only be categorized for the case of nominal variables. It can take in the form of a binary or 3 or more categories or multi-class factors. We also have what we call ordinal. For ordinal level of measurement, the data can be categorized and ranked. A typical example for ordinal type of data include socioeconomic status and all satisfaction rating and several other factors or variables that can be ranked or rated, especially when you are dealing with Likert scale type of instruments. We have the interval. The data can be categorized, ranked, and evenly spaced for the case of intervals. Then ratio. For the ratio, the data can be categorized, ranked, evenly spaced, and has a natural zero. Depending on the level of measurement of the variable, what you can do to analyze your data may be limited. There is a hierarchy in the complexity and the precision of the level of measurement. From low, that is begin from the nominal, to the highest level, that is the ratio level. Note that by going from the lowest to the highest, the 4 levels measurement are cumulative. This means that they each take on the properties of the lower from the nominal. Then before you get to the ordinal, you just add up one different factor or property that makes it different from nominal. So this means that they each take on the properties of lower levels and add new properties to get to the different levels. Importance of levels of measurement. The level at which you measure a variable determines how you can analyze your data. The different levels limit which descriptive statistics you can use to get an overall summary of your data and what type of inferential statistics you can perform on your data to support or refute your hypothesis. In many cases, your variables or your study variables can be measured at different levels. So you have to choose the level of measurement you will use before data collection begins. So the scale of measurement informs the type of data that you will collect, the design, the correlation type, and even the regression technique that you can even use to analyze the situation. Very important to know that. Nominal, ordinal, interval, and ratio data. For the case of nominal levels and specific examples, in nominal levels, you can categorize your data by labeling them in mutually exclusive groups, but there is no order between the categories. The key here is there is no order. I can take any form of category. It can be binary, it can be 2 levels, or multi-class, or more, different levels of categories. Examples of nominal scales could be city or birth. City or birth. It can be gender. It can be ethnicity. It can be car brands. It can be marital status. It can be different levels that may take different categories. As long as the variable, the level of measurement takes 2 or more categories, then it falls under nominal levels. For the case of ordinal level, you can categorize and rank your data in order. Here, the key is in order, but you cannot say anything about the intervals between the rankings. Although you can rank the top 5 Olympics medalists, this scale does not tell you how close or far apart they are in number of wins. You cannot say that. You cannot tell, but it has been ranked. Typical examples for ordinal skills include socioeconomic status. For the case of trade levels, we can say low, medium, and high. The top 5 Olympics medalists is also a typical example. They were ranked the 5th, 4th, 3rd, 2nd, and 1st. Then we have the language ability. We have the beginner, intermediate, fluent. Then even satisfaction rating or levels, which also takes in the form of a like a skill type of question. So for a 5 level, you can say extremely dislike, neutral, like, or extremely like. Or in the typical like a skill type of question, very satisfied, neutral, dissatisfied, and very dissatisfied. We also have income level, which have 3 levels. Specific to this example, you have less than 5K, 50K, 200K, and over 100K. And it's mutually exclusive. We also have the interval level. Here you can categorize, rank, and infer equal intervals. Okay, with the emphasis on the equal intervals makes it different from the ordinal between neighboring data points. Okay, but there is no true 0 point. Take note, there is no true 0 point. That makes it different from the ratio level. So the difference between any 2 adjacent temperatures is the same. 1 degree is what you need to look at. Okay, but 0 degrees is defined differently depending on the scale. It doesn't mean an absolute absence of temperature. So the same is true for test scores and personality inventories. A 0 on a test is arbitrary. It does not mean that the test taker has an absolute lack of what the trait being measured. No, it's just an arbitrary number. Example of interval skills. One, we have what is called a test scores. That's IQ or exams. We have personality inventories at temperature in Fahrenheit or Celsius. Then we also have the ratio level. In this case, that's the highest level. You can categorize, rank, infer equal intervals between neighboring data points. And there is also a true 0 point. A true 0 means there is an absence of variable of interest. In ratio skills, 0 does mean an absolute lack of what? The variable. For example, in a Kelvin temperature scale, there are no negative degrees of temperature. 0 means an absolute lack of what? Thermal energy. Therefore, examples of ratio scales include height, age, weight, temperature, and Kelvin scale. Now, what is central tendency? Central tendency is a statistical concept that refers to the central or typical value of a probability distribution. It is a descriptive summary of a data set that reflects the center of the data distribution. Measures of central tendency help students and researchers to find the middle or the average of a data set. The 3 most common measures of central tendency are the mode, median, and mean. For mode, it refers to the most frequent value or the most occurring number in the distribution. We have the median, that is the middle number in an ordered data set. When we talk about the mean is the sum of all values divided by the total number of values, or simply referred to as the average value. It is the most commonly used measure of central tendency because all values are used in the calculation. So in addition to central tendency, there's a concept of variability or dispersion. So the variability and the distribution of your data set is also important to understand when performing descriptive statistics in every data set. And if you look at this, you have the measure of central tendency, you have the mean, median, mode. The median is the middle value of the distribution. All right. Then we have the mode, that is the most occurring, the peak, the highest. Then we talk about the average. The average is the mean. Central tendencies versus scale of measurement or levels of measurement. Types of data point. You have nominal, ordinal, interval, or ratio level of data set, and its applicability of central tendency. For the case of nominal, you see that mode is present. You can use mode. And for the case of ordinal, you can use both mode and median. Both mode and median. But for intervals, you can use all the three levels. That is the mode, median, and mean. But we have two forms of mean. We have the arithmetic mean and the geometric mean. But for the case of interval, you can only apply the arithmetic mean. Then for the ratio, you can also apply all the means, even including the geometric means. So for the ratio level is the highest level, you can apply the mode, median, mean, arithmetic mean, and geometric means. What is the difference between arithmetic mean and geometric mean? Arithmetic mean is the most commonly used type of mean. That is the traditional mean we see in most of the calculations that we see from the computer output or the software output that we see from every statistical analysis. But we also have a geometric mean. A geometric mean is a method used for averaging values from scales with widely varying ranges for individual subjects. So while arithmetic mean is based on adding the value, geometric means you multiply the values. So for arithmetic, you'll be adding, then you divide by the total observation. But for the case of geometric, you'll be multiplying. Very important to take note of that. Now, what is measure of dispersion or measure of variability, or variability per se? Variability describes how far apart data points lie from each other and from the center of the distribution. How far in terms of the spread of the entire data point from the mean or from the central distribution. Okay, very important to take note of that. Along with measures of central tendency, measure of variability gives you descriptive statistics that summarize your data. Variability is also referred to as the spread, the scatter, and the dispersion. That is why in some books, you will see measure of dispersion or measure of variability. They are all the same. The most commonly measured that we always use when it comes to variability or measure of dispersion includes 1, range, interquartile range, standard deviation, and variance. That's the most common one. Range, that's the difference between the highest and the lowest values from the distribution. So for instance, if you have, let's say, age of participants and the minimum is 10 and the maximum is 60, you have to subtract the 10 from the 60 to get 50. So the range will be 50. Now the interquartile range. Interquartile range here, the range of the middle half of the distribution, the range of the middle half of the distribution. We also have the standard deviation. Standard deviation is the average distance from the mean, the average distance from the mean. Then we have the variance. The variance is the average of square distance from the mean, the average of the square distance from the mean. Okay, so you have to take note of that. Now let's look at the measure of dispersion or variability versus scale of measurement. Types of data points, the nominal, ordinal, interval, and ratio level. In terms of applicability of appropriate measure of dispersion, for nominal, it is not applicable. You can't apply measure of dispersion to nominal data set. But for the case of ordinal, you can apply range and interquartile range. And for the case of interval, you can apply the range, interquartile range, standard deviation, and variance. And even at the highest level, that is at the ratio type of data point, you can apply the range, interquartile range, standard deviation, variance, and even what is called the relative standard deviation. What is relative standard deviation? Relative standard deviation is simply the standard deviation divided by the mean. So this concludes today's lesson. Thank you very much for subscribing to GIS TV, and I will see you all in the next video. Thank you.